4.1, inverse functions. All right, determine whether each function graph or defined as one-to-one. So if they give you a graph that looks like this, they want to know if it is one-to-one. So since so many of you had your notes, one-to-one function is a function that if for elements a and b in the domain of f, a is not equal to b implies that f of a is not equal to f of b. Okay, and we follow the horizontal line test. So basically, as we go this way, if it intersects only one time, then it is one-to-one. So if at any point it intersects only once, so as we go up, there's no point when it's intersecting multiple times. So this is going to be one-to-one. And a lot of times I'll just write like 1-1. So it means the same thing. (14) They give us an upside down, oh, nope, not like that. An upside down absolute value function. So as we go up, we have multiple points where it intersects twice. We're intersecting here and over here. And so this would be not one-to-one. Now, if they gave it to you written as a function instead, so y equals 4x plus 20, any thoughts on what I should maybe do first?
Find
What is this?
that's a y-intercept form.
Okay, so I should maybe do what? Graph it. Sounds like a great idea. So I'm going to count increments of 5 so that I don't have to. I'll do ones on the x-axis though. Okay. All right, so that's at 20. It's a positive slope, so I'm going to go down 4, back 1, so I don't have to keep going up higher. So here, so something like this, but it's an equation of a line. So would this be one-to-one?
Yes.
Yes, because every point going up intersects only once, so this one would be one-to-one. All right, use the definition of inverses to determine whether f and g are inverses. So, what you will see in your notes when you do them is that if we have two functions, we can tell if they're an inverse by plugging one function into the other function. And if we get out just x at the end, so if everything cancels and we're just left with x, then it is an inverse function. Now, your book, some books just say to verify that they are inverses. Yours says to determine if they're inverses, so they may or may not be. But we have to check both ways, so basically each of these problems gets done twice. So let's see, 42. F of x is equal to 3x plus 9. And g of x is equal to 1/3 x minus 3. So we check f of g of x, And we're going to check g of f of x. So anywhere that I see an x and f of x, I'm putting this function g of x. So over here, I'm going to have 3 times 1/3 x minus 3 plus 9. So then distribute in here. 3 times the 1/3 x, that's going to cancel and give you just an x. Then 3 times -3 is -9. Plus 9 on the end. The -9 and the +9 cancel. You're left with an x. So that way we verified that they are inverses, but I have to check the other way just to make sure. So over here we have 1/3. I have an x, so I'm plugging in this function f of x. So times 3x plus 9 and then minus 3. And distribute. 1/3 times 3x cancels and gives you an x. 1/3 times 9 is 3, so plus 3, and then over here minus 3. Those 3's cancel, so we're just left with an x, and so we have verified that these are inverses of each other. So if it comes out to be anything other than an x by itself, like it came out to be 4x or it came out to be x minus 2 or something like that, that would not be an inverse. It has to just be an x by itself at the end. Let's see. 44. F of x is equal to -4x plus 2. G of x is equal to -1/4 x minus 2. So f of g of x. So we got -4 times function g of x going in, so -1/4 x minus 2 plus 2 so then got -4 times -1/4, that's going to be a positive x. -4 times -2 is a positive 8, and then plus 2 out here, so that's going to be x plus 10, and that causes a problem, so I don't need to do the other one. These are not inverses because it's not an x by itself. So if you do it, and let's say you had done g of f of x first and it didn't work, you can immediately say it didn't work. So they're not inverses. Now, if you're not 100% sure if you did the math right and you want to check it and you want to do the other one just to verify, not a bad idea. But as soon as you see that that one didn't work, you can stop. So, all right, let's look at one that's a little harder. 46. F of x is equal to x minus 3 over x plus 4, and g of x is equal to 4x plus 3 over 1 minus x. So notice these ones have 2 x's, okay, in each of them. So that means that the function g of x is getting plugged into f of x 2 times, okay? Everywhere there's an x, it's getting plugged in. So my f of g of x, when I plug it in, it's going to be 4x plus 3 over 1 minus x minus 3 all over, then I've got to plug it in again, 4x plus 3 over 1 minus x plus 4. Now, often here, people's temptation is to cancel that stuff top and bottom because they see that it's there and they're like, oh, I'm just going to cancel it, and then there you're left with the negative 3 over 4. We can't do that, okay? So I need to get a common denominator on top and a common denominator on the bottom. Now, in this case, it's going to be the same denominator, but that, obviously, when we do math, it isn't always the case. So my common denominator is going to be 1 minus x. So I'm going to multiply the negative 3 by 1 minus x over 1 minus x, because it's the same thing as multiplying by 1, and it will give me a common denominator when I'm done with that. On the bottom, I have the same denominator down here, so I'm doing the same thing, 1 minus x over 1 minus x. So now, on top, I'm going to have, copy that part, so 4x plus 3 over 1 minus x. Now, I usually go ahead and put this sign through with it just so things don't get confused. So I'm just going to say plus negative 3 plus 3x over 1 minus x. All over. Do the same thing on the bottom. 4x plus 3 over 1 minus x plus 4 minus 4x over 1 minus x. Are we tracking so far? Yeah, there's a lot happening. Sort of, kind of, maybe. Okay. So, these now have the same denominator, meaning I can add the stuff in the numerators of each one. Okay, so on top, I'm going to have, it's over 1 minus x. So I've got 4x plus 3x, that's going to be 7x. Then I've got 3 minus 3, so that goes away. So on top, I'm left with 7x over 1 minus x. All over. Now I do the same thing on the bottom. It's all over 1 minus x. So 4x minus 4x, so those go away. 3 plus 4 is 7. Now, what do I do when I have a fraction divided by another fraction?
Divide.
Keep, change, flip. So the top one stays 7x over 1 minus x times, and then we flip this bottom one, so it's going to be 1 minus x over 7. So the 1 minus x's cancel, 7's cancel, and finally we're left with an x. So f of g of x worked.
So you have to do that again?
For g of f of x. So I said this one's a little harder.
If one is right, will the other one be right too? Like, will they all be the same? Will they both be the same, either they equal x or they don't?
I'm not going to say 100% of the time yes, but typically if one works, the other one will work.
Oh, same if you look at x plus 5, the other one's x plus 5. Yeah, that could happen, right?
All right, I'm going to draw a line here and do g of f of x on this side. But I got news for you. If you don't check both of them, unless the first one didn't work, if you don't check both of them, I'm taking points off.
What if you just before the problems, you're just yes?
Then I'm going to use my nice large stamp that says show your work on your paper.
I think I've never gotten that stamp before.
I've only used it twice, and that was because the class really made me mad. Because they were not showing their work. They were just throwing answers down on the paper. My favorite is when they give me the wrong answer. So with word problems, a lot of times I use the same word problems, but I change numbers. Because I'm getting them out of the textbook, obviously, so I'll just change the numbers on it. And so this one class, I think 5 out of 7 students gave me the answer for the problem in the book, but not for the problem that was on their test.
That's unfortunate on
and it was really funny. I was like, wow, those numbers on your paper don't match the numbers in the problem. It was interesting. They were really mad afterwards. I was like, don't just memorize answers in this class.
That's good.
All right, let's do the other way. G of f of x. So every time I see x, I'm plugging in f of x now. So I've got 4 times x minus 3 over x plus 4 plus 3 all over 1 minus x minus 3 over x plus 4.
Well, so this one's not as bad, right? Like it's not as long.
I think it'll be shorter. All right, so what am I going to need to multiply the 3 by on top and the 1 by on the bottom in order to get a common denominator? What is the denominator of the fraction? The little fraction in the fraction. Like, what's the denominator of this?
X plus 4.
So whatever that denominator is what we're multiplying by. So this is going to be by x plus 4 over x plus 4. And then down here, it's going to be the same thing. I'm just going to write it on this side because I don't have space on the other side. But so when I do this, I'm going to go ahead and multiply this 4 through just to save writing. So this part here is going to be 4x minus 12. So that 4 is getting distributed on the top. Bottom is x plus 4 plus, distribute here, 3x plus 12 over x plus 4 all over, same thing on the bottom. This is just going to become x plus 4 over x plus 4. I'm going to go ahead and multiply this negative sign through just so I don't forget about it. So plus negative x plus 3 over x plus 4. So now when I combine it, I will have on top 4x plus 3x is 7x. Negative 12 plus 12 is 0. So that's over x plus 4. All over on the bottom, x minus x, that goes away. 4 plus 3 is 7 over x plus 4. So keep, change, flip. So 7x over x plus 4 times x plus 4 over 7. And thankfully, again, everything cancels. Whoops, not the x. Leaving us with x. And so they are inverses.
It's so much. I get it, but it's like...
It's just a lot. But at least the beauty of these problems is you know what your end result is supposed to be.
Yeah.
So it's kind of just like I've got to figure out like the middle part. Now, the downside to this textbook compared to all my other textbooks is that all the other ones, they just say to verify, which basically means they're going to be inverses, just show it. But yours is, well, they might not be, as we saw in the last one. So you at least know what you're trying to get to, and if you get something super crazy, they're probably just not inverses. All right, I want you to try this next one on your own so I can make sure that we're getting it. 48.
Is this another long one?
Sort of, but it's a little easier, in my opinion. Now, I honestly don't know if these ones are going to work out to be inverses or not, so we're going to find out at the same time. Y'all are going to do it, and I'm going to freeze my screen and do it at the same time. So f of x is negative 1 over x plus 1, and g of x is equal to 1 minus x over x. Oh, I don't want my finger on this. So if the first one you do doesn't work, I don't know if it will or won't, you can stop. Do we know yet if they're inverses or not?
I think I still need to see them up there.
I think I got not inverse.
Not inverse. Anyone else? Are we ready to go over it?
I'm gonna say it's not inverse.
You just trust Tristan on this one.
And it didn't take y'all that long, so.
Maybe we're just fast.
I didn't. I did it, but like, I didn't do it. Like, I didn't get an answer.
Tori, Josh, do you have an opinion?
I couldn't figure it out, so I guess
Tori? You don't know or you're saying no? All right, I got not an inverse. So, f of g of x, we'll look at that one first. So I've got -1 over x plus 1. So where that x is, I have plugged in the 1 minus x over x. So then I now have that on the bottom. I need a common denominator here. So in this case, I just needed an x. So I just multiplied by x over x. So they give me that common denominator of an x on the bottom. So then I've got -1 over 1 minus x plus x over x, basically. So I've got -1 on top. Then on the bottom, the negative x and the x here cancel. So I just have a 1 left. And then x in the denominator. Keep, change, flip. So I've got -1 times x over 1. 1's cancel, but that negative sign is still there. And so then I have negative x. And so sometimes also people get confused on that part. A negative x is not an x by itself. So that would have automatically made it not an inverse. But I did the other one in case y'all did them in the reverse order or just to show you the math of it. Any questions on f of g of x before I... If you need a minute to process before I go over g of f of x. Is that what you got, Tristan?
I don't know why I did I multiplied x over x on top too.
It shouldn't have really changed anything for you because it's just 1,
I
but
didn't know if I had to do.
no, you only have to do it if you have the reason we did it in this one is because top and bottoms, because there was already a piece here that was a fraction, but since that was just a number by itself, we don't have to do it. There's no other fraction up there. But it shouldn't have really changed your answer because that would have just been multiplying by 1. Any questions on f of g of x?
We multiplied by x over x to do what?
To get a common denominator on the bottom. Because the g of x function is 1 minus x over x. So that's why we had to do x over x to get that common denominator. And the other problem that we did, it was x minus 3 or something. So we had to multiply by that to get it to cancel. Or not cancel, to get a common denominator. Which ultimately led to it canceling. But
Alright, I get it.
Alright, g of f of x though. So we started with 1 minus x over x. So both places I have that x, I'm plugging in this -1 over x plus 1. So I plugged it in here, plugged it in here. And then I need a common denominator on the top. So I had to multiply by x plus 1 over x plus 1, which is what I did here. Then combining the stuff, I had x plus 1 over x plus 1, because that was just all multiplied by 1, so it didn't change anything. Plus, and that's plus because we had negative times negative, so plus 1 over x plus 1. On the bottom, I just copied it down. Then combining this stuff on the top, we had x plus 1, so x plus 2 over x plus 1. So that's the numerator of that. And then over that bottom part, it just keeps getting copied down. At this point now, I have a fraction over a fraction, so keep, change, flip. So I have x plus 2 over x minus 1, or sorry, x plus 1. times x plus 1 over negative 1. So the x plus 1's cancel, just like they had in our previous problem. But then I have x plus 2 over negative 1 is what's left, so that's going to give me negative x minus 2. Or you could have written it as like negative parentheses x plus 2. And so obviously that wasn't an x by itself, so that one also didn't work, and so they were not inverses. Now, that one was a little bit harder math, so any questions on that one? If you need to take a picture of the work so that you have it, you can do that. To make your life easier later. All right, so the next thing, so if you're like, oh, I'm still confused, we're not done with that stuff yet. The next stuff is actually finding the inverse. So here they gave us two functions, and it said basically to check and see if they are inverses of each other. So now what they're going to do is they're going to give us one function. We're going to find the inverse, and then we're going to check and make sure that they are inverses so that we get more practice on the checking to verify that they're inverses. And these problems pretty much mean there's no reason to get them wrong because you'll know right away if you did something wrong because it won't work when you do the math and plug them back in together. Oh, come back. Number 60. So these problems, just for reference, have a lot of instructions with them, but we're only doing the part that says, it's part A, write an equation for the inverse function. So for problems 59 through 76, we're only doing part A.
So are these like longer or shorter?
Probably shorter, but you have to find the inverse and then we're going to check it. But usually when I check, I will only check one way. I don't usually check both ways just because I'm just verifying that I did my math right. All right, so the key here, which is in your notes, but when finding an inverse, swap x and y. So anywhere there's an x in the original equation, you're going to put a y. Anywhere there's a y, you're putting an x. That's what that means. Swap x and y, solve for y. So, problem 60. Now, they write it as f of x is equal to 4x minus 5. Okay? F of x is also known as y. So if it helps you to think about it, rewrite this as y equals 4x minus 5. Just for the sake of my instructions, swap x and y. Or I could say swap x and f of x, but I'll use y when I'm actually solving the problem. So I swap x and y first. So I'm going to have x is equal to 4y minus 5. So that's step 1. Okay, step 2 is get y by itself. So I'm going to add the 5 over. So I'm going to have x plus 5 equals 4y. Then divide by 4. So x plus 5 divided by 4 is equal to y. And this would be your inverse function. Okay, so this would be f to the negative 1 of x, technically, but you don't need to write it that way. That's just so you know that's your inverse function. So you found the inverse. So now this is kind of like g of x was before, okay? So now to check it, we are going to take the original function. So 4, anywhere we see an x, we're putting this equation now. So that's going here. So x plus 5 divided by 4 minus 5 So 4 cancels. So I have x plus 5 minus 5. 5's cancel. And so I'm left with, what's happening? I'm left with x. So these are inverses. So I know I did it right. Now, the instructions don't say you have to check. I'm not going to require you to check them, but I would highly suggest that you check them. Okay, if for nothing else other than it's more practice checking. But also it pretty much guarantees you won't get the problem wrong. Any questions on this one? And we're going to do several more of them, but no? Okay. All right, let's see. 64. F of x is equal to negative x cubed minus 2. So first thing, I'm going to swap my x and y. So remember that f of x is y. So I'm going to have x is equal to negative y cubed minus 2. So that's part 1. Now I need y by itself. So I'm going to add this 2 over. So I'm going to have x plus 2 equals negative y cubed. I'm going to divide by the negative, so that's going to be negative x minus 2 equals y cubed. And to undo a cube, I take the cube root, so my final answer is going to be the cube root of negative x minus 2 is equal to y. And this would be my inverse to the original function. Now, when we were doing the problem that we had, or the problems that we had for the verifying, we didn't have one that was like this, so this one's going to look a little different in our checking. So here, I'm going to plug this in, okay, up here 4x, so I'm going to have negative. Then I would put it in parentheses, the cube root of negative x minus 2. And that whole thing is getting cubed. Minus 2. So when you have a cube root being cubed, that just undoes itself, okay? So any like roots, like a fourth root raised to the fourth power, a square root being squared, those things just cancel. So I'm kind of just going to scratch those out. So then I've got negative parentheses negative x minus 2 minus 2. So then distributing that negative, I've got x plus 2 minus 2 is x. And so again, I have verified that they are inverses of each other. Now you could do it the other way. You could plug this into this and it's the same thing is going to happen. Totally up to you, but all right, let's get one that's a little bit harder. You think these ones are easy? I can go all the way.
Super easy. Easiest stuff I've ever done.
That's good. I'm glad. 68. This one might not actually be harder, but f of x is equal to 4 over x, and they put the stipulation on it that x cannot be equal to 0, because if x is equal to 0, that function would be undefined. All right, so first step, swap x and y. So I'm going to have x is equal to 4 over y. So then multiply by y, so I get x times y is equal to 4. I need y by itself, divide by x. So y equals 4 over x. And that's my inverse.
Check.
But what do you notice?
It's like slanted. But like.
Yes, it is slanted. Do you want me to fix it?
Oh, I thought that was actually something different.
What do you notice about this and this? My inverse and my original.
It's the same.
They're the same, which kind of looks concerning, right?
Yeah.
Okay, so let's check it and make sure. That was the best thing. It's slanted.
I thought that's what it was. I really.
All right, so I've got 4 over. Now where this x is, I'm putting this 4 over x. So keep, change, flip. I've got 4 times x over 4. 4's cancel. And I'm left with an x. So they are inverses. So sometimes your inverses might be the exact same function. It's very possible.
Is it possible that like both one equals x plus 5 and the other one equals x plus 5, or something like that, or negative x plus 5, or like they both equal the same?
Not really. It's usually going to be a situation like this when they're the same. Just because of the stuff having to cancel. Because if you had x plus 5 and x plus 5 and you plugged that in, you'd end up with x plus 10. Or 2x plus 10. Or, no, yeah, x plus 10. So it wouldn't work that way. Alright, I'm going to give your quizzes back. So I'm going to hold on the more difficult problems for tomorrow, and we'll finish the section tomorrow. So you technically don't need your next section of notes done until Thursday, but you can have homework tomorrow night, so I'm telling you that they're due tomorrow. But if you want to do them tomorrow in class when you do these problems, that's also fine. So, I know you have a game tonight, or some of you have a game tonight,